Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Postgraduate Diploma in Computer Applications, PGDCA, New. Semester 2, MCS 207 Database Management Systems. Block-2 Database Normalization and Database Query. Unit-9 Advanced SQL. 9.0 Introduction. The structured query language, SQL, is a standard query language for database systems. It is considered one of the factors contributing to the success of commercial database management systems, primarily because of the availability of this standard language on most commercial database systems. We have already discussed about SQL in the previous 2 units, where we discussed the SQL commands for data definition, data manipulation, data control, joins, subqueries, etc. In this unit, we provide details of some of the advanced features of structured query language. We will discuss assertions and views, triggers, standard procedures and cursors. The concepts of embedded and dynamic SQL and SQLJ, which are used along with Java, have also been introduced. Some of the advanced features of SQL have been covered. We will provide examples in various sections rather than including a separate section of examples. The examples given here are closer to SQL 3 standard yet may not be applicable to every commercial database management system. For more details, you may go through the documentation of DBMS that you may use for implementation of database. 9.1 Objectives. After going through this unit, you should be able to define assertions and explain how they can be used in SQL. Explain the concept of views, SQL commands on views and updates on views. Define and use cursors. Discuss triggers and write stored procedures, and explain dynamic SQL and SQLJ. 9.2 Assertions and views. One of the major requirements in a database system is to define constraints on various tables. Some of these simple constraints can be specified as primary key, not null, check value and range constraints. Such constraints can be specified while creating the table using the statement create table using the clauses like not null, primary key, unique, check etc. Referential constraints can be specified with the help of foreign key constraints. However, there are some constraints which may relate to more than one table. These are called assertions. In this section, we will discuss 2 important concepts that we use in database systems, viz. Views and assertions. Assertions are general constraints, while views are virtual tables. Let us discuss them in more detail. 9.2.1 Assertions. Assertions are general constraints. For example, a hypothetical university does not admit students whose age is more than 25 years or is more than the minimum age of the teacher at that university. Such general constraints can be implemented with the help of an assertion statement. The syntax of an assertion statement is given below. Syntax. Create assertion. Check. The assertion name helps in identifying the constraints specified by the assertion. These names can be used to modify or delete an assertion later. Assuming that the university has a student and one faculty table, the assertion on the age of students can be implemented as create assertion age constraint. Check, not exists. Select from student S, where S.age greater than 25 or S.age greater than. Select min, F.age from faculty F. An assertion, as above, is enforced on a database system by the database management system such that the constraints stated in the assertion are not violated. Assertions are checked whenever a related relation changes. Example 1. Consider the following relations of a university. Faculty, code, name, age, basic _ salary, medical _ allowance, other _ benefits. MEDICALCLAIM, code, claim date, amount, comment. Write an assertion for the university, which verifies that the total medical claims made by a faculty member in the financial year 2022-23 should not exceed his/her medical allowance. Create assertion total _ medical _ claim. Check, not exists. Select code. These are query modification, view materialization. In the query modification strategy, any query that is made on the view is modified to include the view defining expression. For example, consider the view STUDENTPERFORMANCE. Consider a query on this view is, the teacher of the course MCS 207 wants to find the maximum and average marks in the course. The query for this in SQL would be select max, smarks, AVG, smarks from SUBJECTPERFORMANCE. Since subjectperformance is itself a view, the query will be modified automatically as select max, smarks, avg, smarks from student S, marks M, where S, enrollment no equals M, enrollment no and subject code equals MCS 207. However, this approach has a major disadvantage. Consider that you are repeatedly executing a complex query on a view in a large database system. The query modification will have to be performed for every execution of the query, leading to inefficient utilization of resources such as time and space. The view materialization strategy solves this problem by creating a temporary physical table for a view. However, this strategy is not useful in situations where database tables are frequently updated, as it will require frequent updating of the materialized views. Can views be used for data manipulations? Some views can be used during DML operations like insert, delete and update. When you perform DML operations on a view, such modifications are passed to the underlying base tables. However, not all views allow DML operations. Conditions for the view that may allow data manipulation are: a view allows data updating if it fulfills the following conditions. 1. View created from a single table. The view allows the insert operation if the primary key columns and all the not null columns are included in the view. The view should not be defined using any aggregate function or group. By having or distinct clauses. This is because any update on aggregated attributes or groups cannot be traced back to a single tuple of the base table. For example, consider a view avgmarks course code. A VG mark created on a base table student, saint_id, course code, marks. In the avgmarks view, changing the class average marks for course code MCS 207 to 50 from a calculated value of 40 cannot be accounted for a single tuple in the student base table, as the average marks are computed from the marks of all the student tuples for that course code. Thus, this update will be rejected. 2. The views in SQL that are defined using joins are normally not updatable in general. 3. With check option clause of SQL checks the updatability of data from views, therefore, must be used with views through which you want to update. Views and security. Views are useful for the security of data. A view allows a user to use the data that is available through the view, thus, the hidden data is not made accessible. Access privileges can be given on views. Let us explain this with the help of an example. Consider the view that we have created for teacher, studentperformance. You can grant privileges to a teacher whose name is ABC as grant select, insert, delete on studentperformance to ABC. With grant option, please note that the teacher ABC has been given the rights to query, insert and delete the records on the given view. Please also note he is authorized to grant these access rights, with grant option, to any other user. The access rights can be revoked using the revoke statement. Revoke all on studentperformance from ABC. 9.3 Embedded SQL and Dynamic SQL. SQL commands can be entered through a standard SQL command level user interface. Such interfaces are interactive in nature and the result of a command is shown immediately. Such interfaces are very useful for those who have some knowledge of SQL and want to create a new type of query. However, in a database application where a naive user wants to make standard queries, that too using GUI-like interfaces, probably an application program needs to be developed. Such interfaces sometimes require the support of a programming language environment. Please note that SQL normally does not support a full programming paradigm. Although the latest SQL has full API support, which allows it a full programming interface. In fact, most of the application programs are seen through a programming interface, where SQL commands are put wherever database interactions are needed. Thus, SQL is embedded into programming languages like C, Java, etc. Let us discuss the different forms of embedded SQL in more detail. 9.3.1 Embedded SQL. The embedded SQL statements can be put in the application program written in C, Java or any other host language. These statements sometimes may be called static. Why are they called static? The term static is used to indicate that the embedded SQL commands, which are written in the host program, do not change automatically during the lifetime of the program. Thus, such queries are determined at the time of database application design. For example, a query statement embedded in C2. Determine the status of a booking of a ticket for a train will not change. However, this query may be executed for many different tickets. Please note that it will only change the input parameters to the query, which are ticket number, train number, date of boarding, etc., and not the query itself. But how is such embedding done? Let us explain this with the help of an example. Example 3. Write a C program segment that prints the details of a student whose enrollment number is given as input. Let us assume the relation student, enroll char, 9, name, char, 25, phone, integer, 12, prog_code, char, 3. The C program may be as follows. Add proper include statements. Declaration in C program. Exec SQL begin declare section. Char enroll 10, name, 26, p_code, 4. Int phone. Int SQL code. Char SQL state, 6. Exec SQL end declare section. The connection needs to be established with SQL. Write appropriate connection statements. Program segment for the required function. Printf, enter the enrollment number of the student, scanf, %s. Phone, p_code. From student, where enroll equals, enroll. If SQL code equals 0. Printf, %d, %s, enroll name, phone, p-code. Else, printf, wrong enrollment number. Please note the following points in the program above. The program is written in the host language, C, and contains embedded SQL statements. Although in the program an SQL query, select, has been added. You can embed any DML, DDL or view statements. The distinction between an SQL statement and a host language statement is made by using the keyword exec SQL, thus, this keyword helps in identifying the embedded SQL statements. Please note that the statements including exec SQL are terminated by a semicolon. As the data is to be exchanged between a host language and a database, there is a need for shared variables that are shared between the environments. Please note that enroll 10, name, 20, p_code, 4, etc. are shared variables and declared in C. The colon character in the SQL statement precedes the shared variables to distinguish them from the table attributes. Please note that the shared host variables enroll is declared to have char, 10, whereas an SQL attribute enroll has only char, 9. Why? Because in C, conversion to a string includes a 0 feet as the end of the string. The type mapping between C and SQL types is defined in the following table. C, type SQL type, long, short, float, double, char, I1, integer, small int, real, double, char, I. Please also note that these shared variables are used in the SQL statements of the program. They are prefixed with the colon to distinguish them from database attribute and relation names. However, they are used without this prefix in any C language statement. Please also note that these shared variables have almost the same name, except p_code, as that of the attribute name of the database. The prefix colon distinguishes whether we are referring to the shared host variable or an SQL attribute. Such similar names are a good programming convention as it helps in identifying the related attribute easily. Please note that the shared variables are declared between begin declare section and end declare section, and their type is defined in C language. Two more shared variables have been declared in C. These are SQL code as int, SQL state as char of size 6. These variables are used to communicate errors and exception conditions between the database and the host language program. The value 0 in SQL code means successful execution of SQL command. To disconnect, you can simply give the command disconnect. You must check all these statements from the documentation of the commercial database management system, which you are using. Explanation of SQL query in the given program. In the given SQL query, first, the given value of the enrollment number is transferred to the SQL attribute value, the query then is executed and the result, which may be a single tuple in this case, is transferred to shared host variables as indicated by the keyword into after the select statement. The SQL query runs as a standard SQL query except for the use of shared host variables. The rest of the C program has very simple logic and will print the data of the students whose enrollment number has been entered. Please note that in this query, as the enrollment number is the primary key to the Relation, only one tuple will be transferred to the shared host variables. But what will happen if the execution of embedded SQL query results in more than one tuple? Such situations are handled with the help of a cursor. Let us discuss such queries in more detail. 9.3.2 Cursors and Embedded SQL. Let us first define the term cursor. The database server may allocate a portion of RAM for database interaction and internal processing. This portion may be used for query processing using SQL. This portion of RAM is also called the cursor. What should be the size of memory for the query processing? Ideally, the size of memory allotted for the query processing should be equal to the memory required to hold the query result. However, the available memory puts a constraint on the allotted size. Whenever a query results in several tuples, you can use a cursor to process the currently available tuples one by one. How? Let us explain the use of the cursor with the help of an example. Since most of the commercial RDBMS architectures are client-server architectures, on the execution of an embedded SQL query, the resulting tuples are cached in the cursor. This operation is performed on the server. Sometimes, the cursor is opened by RDBMS itself. These are called implicit cursors. However, in embedded SQL you need to declare these cursors explicitly. These are called explicit cursors. Any cursor needs to have the following operations defined on them. Declare to declare the cursor. Open and close to open and close the cursor. Fetch get the current records one by one till the end of tuples. In addition, cursors have some attributes through which we can determine the state of cursor. These may be ISOPEN, it is true if the cursor is open, otherwise false. Found, not found, it is true if a row is fetched successfully, not successfully. ROWCOUNT, it determines the number of tuples in the cursor. Let us explain the use of the cursor with the help of an example. Example 4. Write a C program segment that inputs the final grade of the students of PGDCA program. Let us assume the relation student, enroll no, char, 9, name, char, 25, phone, integer, 12, prog_code, char, 3. Grade, char, 1. The program segment is add proper include statements. Declaration in C program. Exec SQL begin declare section. Char enroll no, 10, name, 26, p_code, 4, grade is just one character. Int phone, int SQL code. Char SQL state, 6. Exec SQL end declare section. The connection needs to be established with SQL. Write appropriate connection statements. Program segment for the required function. Printf, enter the program code. Scanf, %s. Exec SQL close finalgrade. Please note that the declared section remains almost the same. The cursor is declared to contain the output of the SQL statement. Please notice that in this case, there will be many tuples of students' database, which belong to a particular program. The purpose of the cursor is also indicated during the declaration of the cursor. The cursor is then opened and the first tuple is fetched into the shared host variable followed by an SQL query to update the required record. Please note the use of current, of which states that these updates are for the current tuple referred to by the cursor, while loop is checking the SQL code to ascertain whether more tuples are pending in the cursor. Please note that the SQL code will be set by the last fetch statement executed just prior to the while condition check. How are these SQL statements compiled and error checked during embedded SQL? The SQL pre-compiler performs the type checking of the various shared host variables to find any mismatches or errors on each SQL statement. It then stores the results in the SQL code or SQL state variables. Is there any limitation on these statically embedded SQL statements? They offer only limited functionality, as the query must be known at the time of application development so that they can be pre-compiled in advance. However, many queries are not known at the time of development of an application, thus, you require dynamically embedded SQL that are discussed next. 9.3.3 Dynamic SQL. Dynamic SQL, unlike embedded SQL statements, is built at the runtime and placed in a string in a host variable. The created SQL statements are then sent to the DBMS for processing. Dynamic SQL is generally slower than statically embedded SQL as they require complete processing including access plan generation during the run time. However, they are more powerful than embedded SQL as they allow runtime application logic. The basic advantage of using dynamic embedded SQL is that you need not compile and test a new program for a new query. Let us explain the use of dynamic SQL with the help of an example. Example 5. Write a dynamic SQL interface that allows a student to get and modify permissible details about him, her. The student may ask for a subset of information. Also, assume that the student database has the following relations: student, enroll no, name, dob, result, enroll no, course code, marks. In the table above, a student has access rights for accessing information on his, her enrollment number, but he cannot update the data. Assume that the username used by a student is his, her enrollment number. A sample program segment is given below. Please note that the syntax may change for different commercial DBMSs, declarations in SQL. Exec SQL begin declare section. Char input fields, 50. Char table name, 10. Char SQL query string, 200. Exec SQL end declare section. Print f, enter the fields you want to see n, scanf, %s. SQL query y string equals select input fields. From table name, where enroll no, user. Plus is used as a symbol for concatenation operator. In some DBMS it may be. Assumption, the username is available in the host language variable user. Exec SQL prepare SQL command from SQL query y string. Exec SQL execute SQL command. Please note the following points in the example above. The query can be entered completely as a string by the user. The query can be fabricated using a concatenation of strings. The program segment is language dependent and is not portable to other programming languages or environments. Query modification may be performed, keeping data security in mind. The query is prepared and executed using a suitable SQL exec command. 9.3.4 SQLJ. Till now we have discussed embedding SQL in C. Can you embed SQL statements into Java program? For inserting SQL statements in Java, you use SQLJ. In SQLJ, a preprocessor called SQLJ translator translates the SQLJ source file to a Java source file. The Java file is compiled and run on the database. The use of SQLJ improves the productivity and manageability of Java code as the code becomes somewhat compact. No runtime SQL syntax errors as SQL statements are checked at compile time. It allows sharing of Java variables with SQL statements. Such sharing is not possible otherwise. SQLJ provides a standard form in which SQL statements can be embedded in the Java program. SQLJ statements always begin with the #SQL keyword. These embedded SQL statements are of two categories: declarations and executable statements. Declarations have the following syntax: #SQL context _class name. The executable statements have the following syntax: #SQL, SQL operation returning no output. OR, #SQL result equals, SQL operation returning output. Example 6, write a Java function to print the student details of the student table. For the students who have been admitted in 2023 or later and whose names are like as, assuming that the first two digits of the 9-digit enrollment number represent the year of admission, the required input conditions may be: the enrollment number should be more than 23 million and the name contains the substring as. Please note that these input conditions will not be part of the student display function, rather will be used in the main function that may be created separately by you. The following display function will accept the values as the parameters supplied by the main public void dispstudent string enroll no string name int phone opening curly bracket dot try sale row iter srows equals null #SQL srows equals select enroll no name phone from student where enroll no greater than 230 million and name like as %. While srows next int enroll no equals srows enroll no string name equals srows dot name int phone equals srows phone system.out println enrollment underscore no equals enroll no system.out println name equals name system.out println phone equals phone catch exception a system.out println error accessing database a to string. 9.4 Stored procedures and triggers. In this section, we will discuss some standard features that make commercial databases a strong implementation tool for information systems. These features are triggers and stored procedures. Let us discuss them in more detail in this section. 9.4.1 Stored procedures. Stored procedures are collections of small programs that are stored in compiled form. A stored procedure is designed for the implementation of a specific function. For example, a company may have rules such as a code, like an enrollment number, contains a check digit to check the validity of the code. The date of change of any value may be recorded. These rules may apply to every application that uses that code. Thus, instead of inserting them in the code of each application, they may be put in a stored procedure and reused. The use of procedure has the following advantages from the viewpoint of database. Application development. They help in removing SQL statements from the application program, thus making the program more readable and maintainable. They run faster than SQL statements since they are already compiled in the database. Stored procedures can be created using create procedure statement in some commercial DBMS. Syntax: create or replace, procedure, user, argument data type, begin, host language statements, end. Example 7. Consider a data entry application that allows entry of the enrollment number, first name and last name of a student. The application then combines the first and last name and enters the complete name in uppercase in the table student. The student table has the following structure: student, enroll no, char, 9, name, char, 40. The stored procedure for this application may be written using an embedded programming language as create procedure student entry, enrollment INOUT char, 9, F underscore name INOUT char, 20, L underscore name INOUT char, 20. Begin. Change all the characters to uppercase and trim the length. F underscore name equals trim, upper, F underscore name. L underscore name equals trim, upper, L underscore name. Name equals F underscore name EL underscore name. Insert into customer. Values, enrollment, name. End. INOUT used in the host language indicates that this parameter may be used both for the input and output of values in the database. While creating a procedure, if you encounter errors, then you can use the show errors command. It shows all the errors encountered by the most recently created procedure object. You can also write an SQL command to display errors. The syntax for finding an error in a commercial database is select from USERERRORS, where name equals procedure name and type equals procedure. Procedures are compiled by the DBMS. However, if there is a change in the tables, then the procedure needs to be recompiled. You can recompile the procedure explicitly using the following command: alter procedure underscore name compile. You can drop a procedure by using drop procedure command. 9.4.2 Triggers. Triggers are somewhat like stored procedures except that they are activated automatically. When is a trigger activated? A trigger is activated on the occurrence of a particular event. What are these events that can cause the activation of triggers? These events may be database update operations like insert, update, delete, etc. A trigger consists of these essential components: an event that causes its automatic activation, the condition that determines whether the event has called an exception, the action that is to be performed. Triggers do not take parameters and are activated automatically, thus are different to stored procedures on these accounts. Triggers are used to implement constraints among more than one table. Specifically, the triggers should be used to implement the constraints that are not implementable using referential integrity or constraints. An instance of such a situation may be when an update in one relation affects a few tuples in another relation. However, please note that you should not be over-enthusiastic for writing triggers if any constraint is implementable using declarative constraints such as primary key, unique, not null, check, foreign key, etc. Then it should be implemented using those declarative constraints rather than triggers, primarily due to performance reasons. You may write triggers that may execute once for each row in a transaction called row-level triggers, or once for the entire transaction, called statement-level triggers. Remember that you must have proper access rights on the tables on which you are creating the trigger. The following is the syntax of triggers in one of the commercial DBMSs. Create trigger. Before, after, on, 1, for each row. Begin, exception, end. Let us explain the use of triggers with the help of an example. Example 8. Consider the following relation of a student's database. Student, enroll no, name, phone. Result, enroll no, course code, marks. Course code, see name, details. Assume that the marks are out of 100 in each course. The passing marks in a subject are 50. The university has a provision for 2% grace marks for the students who are failing marginally, that is, if a student has 48 marks, S, he is given 2 marks grace, and if a student has 49 marks, then S, he is given 1 grace mark. Write the suitable trigger. For this situation, please note the requirements of the trigger. Event, update of marks. OR, insert of marks. Condition, when a student has 48 Oregon 49 marks. Action, give 2 grace marks to the student having 48 marks and 1 grace mark to the student having 49 marks. The trigger for this thus can be written as create trigger grace. After insert OR update of marks on result. When marks equals 48 OR marks equals 49. Update result. Set marks equals 50. We can drop a trigger using a drop trigger statement. Drop trigger trigger underscore name. The triggers are implemented in many commercial DBMS's SQL. Please refer to the documentation of the respective DBMS for more details. 9.5 Advanced features of SQL. The latest SQL standards have enhanced SQL tremendously. Let us touch upon some of these enhanced features. More details on these would be available in the online sources of SQL. SQL interfaces. SQL also has good programming level interfaces. The SQL supports a library of functions for accessing a database. These functions are also called the Application Programming Interface, API, of SQL. The advantage of using an API is that it provides flexibility in accessing multiple databases in the same program irrespective of DBMS, while the disadvantage is that it requires more complex programming. The following are 2 common functions, called interfaces. SQL, CLI, SQL Call Level Interface, is an advanced form of Open Database Connectivity, ODBC. Java Database Connectivity, JDBC, allows object-oriented Java to connect to multiple databases. SQL support for object orientation. The latest SQL standard also supports object-oriented features. It allows the creation of abstract data types, nested relations, object identifiers etc. Interaction with newer technologies. SQL provides support for XML, extended markup language, and online analytical processing, OLAP, for data warehousing technologies. 9.6 Summary. This unit has introduced some important advanced features of SQL. The unit has also provided information on how to use these features. An assertion can be defined as the general constraint on the state of a database. These constraints are expected to be always satisfied by the database. The assertions can be stored as stored procedures. Views are the external schema windows of the data from a database. Views can be defined on a single table or multiple tables and help in automatic security of hidden data. All the views cannot be used for updating data in the tables. You can query a view. The embedded SQL helps in providing complete host language support to the functionality of SQL, thus making application programming somewhat easier. An embedded query can result in a single tuple. However, if it results in multiple tuples, then you need to use cursors to perform the desired operation. Cursor is a sort of pointer to the area in the memory that contains the result of a query. The cursor allows sequential processing of these result tuples. The SQLJ is the embedded SQL. For Java, dynamic SQL is a way of creating queries through an application and compiling and executing them at the runtime. Thus, it provides a dynamic interface. And hence the name. Stored procedures are precompiled procedures and can be invoked from application programs. Arguments can be passed to a stored procedure and can return values. A trigger is also like a stored procedure except that it is invoked automatically on the occurrence of a specified event. You should refer to the further readings for more details on the topics relating to this unit. Thank you for watching. We will see you in the next video with the next chapter.